we had seen that numbers that are not rational are called irrationals, and further, irrational numbers, after the decimal, the digits keep on repeating, they do not terminate, so they are non-terminating decimals, and also non-recurring. That is, the digits after the decimal do not repeat or recur in a particular sequence. So this is irrational numbers which are non-terminating and non-recurring. Now, how do I plot these irrational numbers on a number line? That is the question. We'd seen integers on a number line. Between any two integers, we'd seen fractions. That is the rational numbers, which are integers plus fractions. Now, how do I plot these irrational numbers? Where do they lie on the number line? So let's start with irrational number root 2. We want to plot under root 2. That is, we know that that's an irrational number. Now let's take a unit distance here and a unit distance vertically. So 1, this is 1, a unit distance, and this is also 1. Now if I join these two lines, I get a triangle. Not just that, I get a right angle triangle. Horizontal, vertically, they are at right angles, and I get a triangle. So I know I have a right angle triangle. Now as soon as I have a right angle triangle, what strikes me is the Pythagoras theorem. So I can apply Pythagoras theorem here. Let's say that this is L. The length of this purple line here is L. So applying Pythagoras theorem, I can say this is the hypotenuse opposite to the right angle, that L square would be equal to the sum of squares of the other two sides. This is 1, this is also 1. So it would be 1 square plus 1 square. So L square turns out to be 1 square, which is 1, plus 1, which is 2. Taking positive square root, I get L as under root 2. Why positive? Because this length has to be positive. We can ignore the negative square root. So I get that this length, this purple side is of length under root 2. So now, how do I plot under root 2 on the number line? I know this is under root 2 distance, this point from this point, but I need to find under root 2 distance on the number line. This point does not lie on the number line. So what do? I take this as my center, I take under root 2 as my radius, and I draw a circle around it with this as center, that is 0 as the center, and root 2 as radius. So if I draw a circle, I get this. Now I know that this line, which is under root 2, is nothing but the radius of this circle. If I take any other point on this, let's say I take this point on the circle. Now I know that the radius has to be the same. So if I look at this point and see its distance from 0, this should also be under root 2, because this is nothing but radius of the circle. This is the center, a point on the circle. So that means any point on this circle would give me under root 2 length from 0. That is the radius. So now let's look at this point. I wanted a point which lies on the number line. Let's look at this point, and similarly this point. From 0, in front of 0, this is behind 0. So again, this point would be what? This point which I get would be under root 2. This point. Why? Because it's again radius under root 2. So this under root 2 is actually the length which is from 0 to this point. So this is the radius of this circle. So this is under root 2. Similarly, you can say that this point would be minus under root 2. Negative of under root 2. So which is this length. Distance is the same. The length is the same. What changes is just the direction. Magnitude is the same. Direction changes a negative number. You get a negative number. So this is how you can plot under root 2 on the number line. So I get under root 2 on the number line which lies between 1 and 2. I get under root 2. Now can we find under root 3? So I know this is under root 2. Again, I take 1 vertically, distance 1, this is under root 2. Now completing the triangle again, I get that this is a right angle triangle. This is a right angle triangle. This is the hypotenuse. I want to find this distance. Again, applying Pythagoras theorem, I can find the length of this purple line, which is L. So L would be what? L square would be, hypotenuse square is sum of the other two sides, sum of squares of the other two sides. So this would be under root 2 square plus this is under root 2, this is 1. So what I get is under root 2 square is number 2 plus 1. This is 3. L square is 3. Taking positive square root, I get L as under root 3. Length cannot be negative, so I ignore the negative square root. I get L as under root 3. So this is what I get. Now again, I need to find this number on the number line. So what I do is, I take 0 as the center, under root 3, this purple line as the radius, and I draw a circle around it. Now again, any point on this circle would be under root 3 distance away from 0. So I mark this point. So this would be under root 3. This point would be under root 3. That is the distance from 0 till this point would be under root 3. And that's how I can mark under root 3 on the number line. So that's how I get under root 3 also on the number line. Similarly, what you can do is, if you take this same distance on the opposite side, that is this point, you can also find negative of under root 3. Same distance, but in the opposite direction. So that's how you can find under root 3. Now can you locate under root 5 on the number line? Under root 2 we found, under root 3 we know, under root 4 is nothing but number 2. Now what would under root 5 be? Where would that lie on the number line? So let's see. Let's take the unit distance 2 now. This 2 unit distances. This is 2. This is 1. 1 unit distance vertically. Now again, if I complete this triangle, this would be a right angle triangle where this line is nothing but the hypotenuse opposite to the right angle. And I can find the hypotenuse applying the Pythagoras theorem in a right angle triangle. So applying Pythagoras theorem, if this is L, I can say that L square, hypotenuse square, would be sum of squares of the other two sides. This side is of length 2, 1 plus 1. So 2 square plus this side is 1, 1 square. So I get 4 plus 1, which is nothing but 5. So L square turns out to be 5. What would L be? Since L is the length, I'll take the positive square root. Length cannot be negative. So L would be positive square root 5. So I get L as under root 5. So this length is root 5. That is the distance of this point from 0 is root 5. Now I need to find this point on the number line. Where would it lie on the number line? So again, taking 0 as the center and this length root 5 as my radius, I draw a circle. You see, we can draw a circle. Now the point where it touches the number line, this gives me under root 5, and in the other direction I get negative of root 5. So you can see it touches the circle at 2 points. This circle touches this line at 2 points, which gives me under root 5 and negative of under root 5. So this point is nothing but under root 5. Now you can see that drawing this circle takes a whole lot of space. So instead of this drawing this circle every time, all you can do is, with this is center and this is radius, just draw a part of this circle, an arc, which cuts the line, the number line, at a point. So what I do is, instead of drawing the whole circle, with this as center and this as radius, I draw a small arc that cuts the number line. Now I know where the point where this arc meets the number line gives me the point root 5. That is the radius. The length from 0 to this point is root 5, which gives me the position of under root 5 on the number line. So we've seen how to plot under root 2, under root 3 and under root 5 on a number line. You can plot other irrationals too following the same method.